we are learning basics of differentiation. The first equation that we need to study is this. Suppose there is a equation which is y equal to k, which is a constant, into x to the power n. Then the first derivative is given as dy by dx. It is the derivative of y with respect to x. This is written as the constant k into that power n into x raised to that power n minus 1. So this is a standard equation. For example, suppose y equal to 5x square, then what is dy by dx? dy by dx is 5 into 2 into x to the power 2 minus 1, which is 10x. So you always do like this: 5 into 2, 10. Then reduce that power by 1, so you will get 10x. But the variables can change. Suppose you get an equation like a v, which you normally physics you get v equal to 5t cube, and it is asked what is dv by dt. Then you do the same thing: 5 into 3, 15 t square. Another one, suppose x is given as 6t square plus 7t. What is dx by dt? You do the same thing for 6t square, then 7t, and then add their results. So 6t square will give you 6 into 2, 12, 12t, 2 minus 1 is t, plus here 7 into 1, power is 1, 7 into 1 into t raised to 1 minus 1. 1 minus 1 is 0, t raised to 0 is 1. So this will give you 12t plus 7. You can differentiate like a chain. For example, suppose you have x equal to 5t square plus 7t cube. First derivative means you differentiate it the first time, dx by dt. Just like we did 5 into 2, 10 t, 2 minus 1, plus 7 into 3, 21 t. Reduce the power by 1. So from 3 you write 2. This is the first derivative. We can again differentiate in the same way. But when you differentiate that in the second time, what you write? The normal way of writing is d square x by dt square. See, in the first term you put the power for d, second term you put the power for t, d square x by dt square, and this gives you same method. The power here is 1. So when the power is 1, you should know that it is 10 into t raised to 1 minus 1. 1 minus 1 is 0, t raised to 0 is 1. So whenever you get 10t, answer will become 10. Plus here 21 into 2, that is 42. Reduce the power. Let us do one differentiation with where there is a constant. For example, assume that y is given by 3t cube plus 2t square plus 5. When you differentiate with respect to time, dy by dt, this will give you 3 into 3, 9t square plus 2 into 2, 4t. But this is 5. Whenever you see a constant, the derivative is 0. Take one more example. This time I am giving you position of a particle. Position is given as x equal to 5t square minus 2t plus 3 meter. What is velocity? Velocity is the first derivative, that is dx by dt. Do the same thing. This is power 2. 2 into 5 will give you 10 t, power 2 minus 1, 1, plus, minus. If you have minus sign, you use minus sign. 2 into t is 2. Then 3 is a constant, so that will give you 0. How to get acceleration? Acceleration is a, which is the first derivative of velocity, but which is also the second derivative of the position. So you take this last equation 10t minus 2, okay, 10t, differentiating you will get 10, then 0. Since the position is given in meter, velocity will be in meter per second and the acceleration will become 10 meter per second square. You can see this acceleration is independent of time. There is no t here, so this is a constant value. This is constant acceleration. So the first equation represents uniformly accelerated motion. Let us do some trigonometric functions. Suppose y equal to sin x, then dy by dx is given by cos x. Similarly, if y equal to cos x, then dy by dx equal to minus sin x. Many times you have equations like y equal to sin 2x, then what to do? Then when you take derivative dy by dx, what to do? You take this sin 2x just like your sin x. So if it is sin x, you will get cos x, and if it is sin 2x, you will get the cos 2x. But you multiply it by the derivative of this 2x. Derivative of 2x is 2. So dy by dx of sin 2x is 2 cos 2x. Apply the same thing for y equal to cos 3x. How to do this for cos 3x? Dy by dx equal to, if it is cos x, you get minus sin x, and if it is cos 3x, you get a minus sin 3x, but you multiply by 3. Multiply by 3, so the answer must be minus 3 sin 3x. So understand what is done. Treat cos 3x just like cos x. If it is cos x, you get minus sin x. If it is cos 3x, you get minus sin 3x. Now multiply it by the derivative of this 3x, and that is a constant, and you will get it as 3 here. This is useful in the chapter oscillation, where you have the displacement y in terms of time. For example, suppose you have displacement 5 sin omega t, 5 sin omega t. Then how to find the derivative of this with respect to t? First you take 5 constant. Then what is the derivative of sin omega t? Sin omega t derivative should be in the form cos omega t, but here omega is a constant, so you multiply it by omega. So you will get this as 5 omega cos omega t. Yeah, treat it like a sin 2x, sin 2x or sin 3x, what we that we did earlier. So just like that, 5 omega cos omega t. Okay. Suppose y is given by a cos omega t. Here a is a constant, omega is a constant, and you are going to differentiate this with respect to t. So what to do? Keep that a over there. Then look at this omega t. Omega is a constant. Take omega here. Then the derivative of cos omega t is minus sin omega t. So total you will get minus a omega sin omega t. This is very much important in the chapter oscillation. The above method is useful in this question. Suppose that you are given momentum equal to sin 2t I plus cos 2t j. How to find force? Force is the rate of change of momentum dp by dt. Okay, and sin 2t is like sin 2x. That will be 2 into cos 2t in the I direction. Cos 2t is like cos 2x. Derivative must be minus, but there is a constant 2 here, so this is minus 2 sine 2t j. Okay, so the second one gives you force, the first one is momentum. And you can see that if you take the dot product of the first two, momentum and force, okay, then you will get a 0. Because this is actually force vector. If you take a dot product of F and P, you can see that the first term 2 sine 2t cos 2t, second term minus 2 sine 2t, there is t here, sine 2t cos 2t, and that is equal to 0. If dot product is 0, that means force is perpendicular to momentum. Then we can study the product rule. That means suppose you have y equal to u into v, then what is dy by dx? dy by dx is u into dv by dx plus v into du by dx. Suppose you have y equal to x square into sin x, then you have two functions, one is x square and the second one is sin x. Okay, now you can find out dy by dx using this method. You can see first function is x square, so you keep x square here, then take the derivative of sin x with respect to x, that's u into dv by dx. So x square into derivative of sin x will become what? It will become cos x. Then plus take the second function which is sin x into derivative of the first one, that is 2x. So that will be your answer. The answer will be x square cos x plus 2x sin x. Suppose you get an equation where x equal to t square e raised to t, then what is dx by dt? You can see there are two terms here. One first function is t square, second function is e raised to t. This is your u, this is your v. First you take a u into derivative of the second one, right? So you first write t square, then take the derivative of e raised to t. Derivative of e raised to t is e raised to t itself. There is no change. Okay, if y equal to e raised to x, then the derivative dy by dx is also equal to e raised to x. Okay, so you did the first part, u into dv by dx is over. Now plus write the second function e raised to t, then take the derivative of the first one. What is the derivative of t square? Derivative of t square is 2t. So this will give you t square plus 2t is common, is there, and e raised to t is common, e raised to t. So that is your answer. Now the quotient rule. That means you have a function y in the form u divided by v, one function by another function. Then how to find the derivative of that one, dy by dx? Okay, it is done like this one. The lower function is v, take v, then take the derivative of the second one, v into du by dx, then put minus, then write the reverse, u into dv by dx, then all of this is divided by v square. For example, suppose y is given by x square divided by sin x, then dy by dx will be equal to, look at this, if you want you can start like this one, you can put sin v square, v is sin x, so here x square is your u, sin x is your v, so in the denominator you need v square, so v square is nothing but sin square x, and on the top you start from v is sin x into derivative of u which is x square, so that will give you 2x, then put the minus sign, then write x square, that is your u, into derivative of sin x, and derivative of sin x is cos x. So that is our answer, 2x sin x minus x square cos x by sin square x. As for practice, try these questions. Okay, first one, position is given, find velocity and acceleration, differentiation. And second one, momentum is given, find force. Again you can see it is given by the first derivative, and it is given t equal to 1 second in both questions. What to do in the final equation? Wherever there is t, substitute it as 1, and you can check your answer. Answer will be for the first question, velocity will be 6 meter per second and acceleration will become 8 meter per second square. In the second case, the force will be equal to 6 Newton.